Okay, so this chapter is determining volume, which is what we've kind of been doing already, but it's maybe doing some actual measurements yourself in order to calculate them, but still using the same formulas that we have been. You'll notice on the left it says what you'll need, so we're going to keep it to a ruler. So if you can grab a ruler, you can do some of these measurements as well. Okay, so it says each side, in the try these, each side length, diameter, and height of these objects is 1 centimeter. List the names of the objects in order from least to greatest volume. So you can take a few minutes and do some calculations if you want, remembering that 1 centimeter is sort of the magic number. So in that case, if you even just look at them, the cube is going to be the biggest. Length times width times height, 1 centimeter cubed. Okay. Remember the relationship between a cube and a pyramid with the same base. This would be 1/3 as much, so obviously it's smaller. If we think about the cylinder, okay, so that cylinder is going to fit in there. There's a circle kind of thing, and then it goes all the way along there. It's probably going to fill up it the second most, okay, but then if we compare that to a cone with the same base, the cone is 1/3 of the cylinder. And then if we think of the sphere going in here, the sphere is going to have a lot of empty spaces around each of the corners. So I would say, you can do some calculations because the sphere is the hardest one to sort of compare here. But this cone is going to be smaller than the cylinder. Okay, so I'd say the cone is the smallest. The pyramid is going to be smaller than the cube. Which one of these looks smaller? Well, the cone does, right? Because this actually goes out to the corners. So then I'd say the pyramid. Okay, and then probably this is where you'd have to actually do some calculations. Where does the sphere fit in? The sphere would fit in before the cylinder because of those rounded edges. So the sphere, and then the cylinder, and then the cube. Okay, so you can actually, if you want to do the calculations, you can. I'm not going to take the time to do those. Okay, so Fatima wonders what volume of paper is in this workbook. So the workbook, take a look at it. What type of object is it? It's all made up of rectangles, all the sides, so that it's a rectangular prism. Or rectangular based prism, I guess, is probably better. Okay, so measure its dimensions, the length, width, and height in millimeters. So grab a ruler and do that. So when I measure it, I get basically 27.5 centimeters long. So that's 275 millimeters. I got a width of a little more than 21 centimeters. So 212 approximately millimeters. And a height, I got about 1.5 centimeters, which is 15 millimeters. So the volume, rectangular prism's the easiest. You just multiply these all together. So what is that? 874,500. 874,500 millimeters cubed. Okay. You might have, like, that one I probably would do in centimeters cubed, but it's just practicing different units. Okay, the next one, it's a stack of DVDs. Not that you guys use DVDs that much anymore, but especially for computer programs and stuff like that, we used to buy them in a big stack. It says, what volume to the nearest cubic centimeter does a stack of 25 DVDs have? Tabitha measured each DVD as 1.2 millimeters thick. So what tools could Tabitha have used to measure the dimensions of a DVD? Well, obviously a ruler. Now, for small measurements like that, there are measuring devices. They're actually pictured on the next page. If you turn over, oh, I guess I don't have it there. I didn't copy it out, but they're calipers or micrometers, or micrometers, I guess is the right way to say it. So those are other options if you really needed to. Those are good for really getting more accurate, especially small items. Calipers are good for anything that's rounded, because really it's hard to tell. If you were to, say, take like a golf ball and try to measure the diameter, you kind of have to eyeball it, right? And so that's tricky. But if you had a caliper, you can fit it in there and it will measure it for you. Okay, so volume of one DVD. Okay, so the radius is, so the diameter here is 120 for the outside. Remember, there's a hole in the middle, so that hole has a diameter of 15. So the radius there is 7.5. The radius here is 60, both in millimeters. So 60 squared times the height is 1.2. We're just doing this for one DVD. Then we're subtracting the inside circle, which is 7.5. So pi times 7.5 squared times 1.2. So get out your calculator. We'll do these separately. So pi times 60 squared times 1.2. So 13,571. Point 6803, and then the inside is pi times 7.5 squared times 1.2 to 12.0575. And so you can get your calculator to subtract those. If you don't have the ability to go back, you just copy out what you wrote down to those 4 decimal places. I think I rounded that to the nearest 3, yeah, 0.3. And then subtract 212.0575. And then oops, that's not what I wanted. 6228. Okay, then on the next page, so we multiply 25 by the volume of a DVD, and we get 333,990.57 millimeters cubed, but it's now asking us for centimeters cubed. So remember that there's 10 centimeters in, 10 millimeters in a centimeter. So if we cube that would be 1,000 millimeters cubed. in 1 centimeter cubed, so we want to divide by 1,000. So 1, 2, 3. That would be 333.99057. And to the nearest cubic centimeter, the nearest whole number would be 334. Okay, so that's this chapter. So now you can work on the practice.